everyone! In the last session, we just learned what geothermal energy is. It is the Earth's heat energy. Let's do a quick recap. Magma, or very hot liquid rocks, can be found underneath the Earth's crust, and it will heat up the water that is found underground. Sometimes magma and hot water can find a way back up to the Earth's surface, creating volcanoes and geysers. But many times, hot water and steam are trapped underground, and they form geothermal reservoirs. These reservoirs can sometimes be found in shallow grounds, a few hundred feet deep, or in deeper grounds, going several miles below. And in order to access the geothermal energy, we must drill into the ground and tap the source. Next, we use a system of pumps that will allow the steam and hot water to travel up. The steam is then used to spin a turbine, which is a machine that has a propeller-like part that spins to generate electricity. And if we break it down into 3 simple steps, all geothermal energy power plants tap a source, spin a turbine, and then replenish the geothermal reservoir. What I mean by that is any hot water or steam that travels up through these pumps is eventually cooled down, creating a byproduct that is actually ready to be pumped back into the ground so that the geothermal reservoirs do not run out of water. And something that's very important to know is that there are 3 different types of geothermal reservoirs. And so we have to think of 3 different ways of accessing it. The first scenario is when a geothermal reservoir only has steam inside of it, we use a dry steam power plant. The first step is to drill into the ground and tap the source, allowing the steam to go up through the pump and directly spin the turbine, which generates electricity. Again, steam is water in the gas form, and as it travels through the system, it cools down and it condenses, which just means that the gas water is turning now into liquid water. This new liquid water that is cooled down is ready to be pumped back into the geothermal reservoir so we do not run out of this great, valuable resource. Now, consider a case where the hot water underground in the geothermal reservoir is at least 350 degrees Fahrenheit. In this case, we still go through the same process of tapping the source and allowing the hot water to flow through the pumps. And now this time, instead of going directly to spin the turbine, there is a flash tank. This flash tank has a lower pressure, which allows the hot water to vaporize immediately. In other words, the liquid water is literally flashed into steam. And then this steam is used to spin the turbine, which creates electricity. And like we mentioned before, the steam condenses and water is pumped back into the ground to the geothermal reservoir. Now, we just said that a flash steam power plant is used when water is at least 350 degrees Fahrenheit. There are times where a geothermal reservoir may have water that is less than 350 degrees Fahrenheit. And although that is still very hot, it may not be hot enough to create an efficient system where enough steam is powered and created to turn and spin the turbines. So in that case, we use a binary power plant. The first step is always the same. You drill the ground and tap into the resource. Hot water will travel through the pump. And instead of the hot water being used to create a steam, this heat exchanger will allow the hot water from the geothermal reservoir to actually boil a secondary liquid that turns into steam much more easily because it has a lower boiling point. Then that steam is used to spin the turbine and create electricity, and the liquids in its respective pump system is cooled down and used again. So in our case with the geothermal water energy source, it is being replenished by going up this pump and then going back down into the earth. So now you know how geothermal energy is stored and then accessed.